This is the Honors Pre-Calculus Final Exam 2013, question number 34. So we're still solving an equation on the interval 0 to 2 pi, and my equation is cosine x equals sine x. So my equation, cosine x equals sine x, and the interval is from 0 to 2 pi, and we're including the 0 but not the 2 pi. That's what the square bracket and the round bracket mean. Now, when I go to solve this, it doesn't seem like there's much to do. What am I going to do with cosine x and sine x? They don't seem to have much to do with each other. I can try subtracting or dividing. It's not going to get me anywhere. So what I want to notice is I don't have any kind of relationship between cosine and sine, so I can't put them together. But I do have a relationship between cosine squared and sine squared. So what I can do is square both sides of this equation. Now when I do that, you have to remember, this is a technique we use for solving radical equations. We square both sides. But when you do that, it's possible to get a false solution if you square, but they call it an extraneous solution. So we're going to have to watch for extraneous solutions because we have squared both sides of an equation. And anytime we do that, it's a non-reversible step. So just because this squared equals this squared, it doesn't follow that cosine equals sine. So that's why we have to check for the extraneous solutions. All right, so if I square both sides, then what I'm going to get is cosine squared x equals sine squared x. Now I'd like to somehow put these terms together, but I can't because one's cosine, one's sine, they're sort of fundamentally incompatible. So what I can do is say, all right, well now that they're squared, I know what cosine squared is in terms of sine. It's 1 minus sine squared. Now that I've got the entire equation in terms of sine, I can solve for sine of x. So now I can add the sine of x to both sides, and I'm going to get 1 equals 2 sine squared x. Now I can divide both sides by 2 and get 1/2 equals sine squared x. But I'm really interested in what x is. So I'm going to take the square root of both sides to get rid of that square. And when I take square root of both sides, of course, I pick up a plus minus. So now I'm going to have plus minus the square root of 1/2 equals, and square root and squared will cancel out, so I just have sine of x. Now I have to do a couple of things here. I guess I just need to simplify this radical. I can't really get rid of that plus or minus by any means at this point. But this 1/2 is equal to square root 1 over square root 2. And square root of 1 is just 1. And square root 2 we cannot leave as a radical in the denominator. So we're going to multiply the top and bottom by square root 2 to rationalize that denominator. Now I have plus or minus square root 2 over square root 2 times square root 2 is square root 4, which is just 2. And now I have plus or minus square root 2. This is all just looking at our plus minus square root 2. So now I know that what sine x is really equal to is plus or minus square root 2 over 2. That equals sine of x. So now I can do inverse sine of square root 2 over 2, but again I'm going to lose the exactitude that I have by working with the radical. So it's much better to look at the unit circle, and let's look at the unit circle, and especially because we have this number square root 2 over 2. I know that number is on the unit circle, so all I have to do is know where that is. So I'm looking for where the sine, that's the y-coordinate, is equal to square root 2 over 2, positive or negative. Well, right here is a point, and that's our pi over 4. And if I know my unit circle, not memorize, but know and understand the unit circle, then I know that the coordinates of this point are square root 2 over 2, square root 2 over 2. So the y-coordinate is square root 2 over 2, making pi over 4 a solution to this equation. Over here I have a point where the y-coordinate is also square root 2 over 2. This is the point 3 pi over 4, where the coordinates are negative square root 2 over 2, positive square root 2 over 2. And I'm not really concerned with the x-coordinate, I'm concerned with the y-coordinate because it's a sine equation. Well, now what about when sine is negative square root 2 over 2? Well, I can go down here to where the coordinates of the point are negative square root 2 over 2, negative square root 2 over 2, and that point is 5 pi over 4. And that's a point where the y-coordinate is equal to negative square root 2 over 2, which also is a solution to this equation. And then over here in this quadrant, I have 7 pi over 4, where the coordinates are positive square root 2 over 2, negative square root 2 over 2. And this negative square root 2 over 2 makes 7 pi over 4 also a solution to this equation. All right, now I seem to have 4 solutions between 0 and 2 pi where the sign is equal to plus or minus square root 2 over 2. So let's list out those potential solutions I have here, which is x equals pi over 4, x equals 3 pi over 4, x equals 5 pi over 4, and x equals 7 pi over 4. Now I need to check each of these to see if it's extraneous or not. So let's start with pi over 4. Is it true, going back to our original equation, not the squared one, but the original equation where cosine x equals sine x, that's the equation that these all purport to be solutions to. So let's see if it's true. Is it true that cosine of pi over 4 is equal to sine of pi over 4? Well, again, if I know my unit circle, I know that cosine of pi over 4 is square root 2 over 2, and sine of pi over 4 is also square root 2 over 2. So yes, that one checks out. Pi over 4 is a solution. Now let's try x equals 3 pi over 4. So I'm going to say, is it true that cosine of 3 pi over 4 is equal to sine of 3 pi over 4? Well, cosine of 3 pi over 4 I know is, if I can look at my mini unit circle up here, it's negative square root 2 over 2. And sine of 3 pi over 2 is positive square root 2 over 2. So these are not equal. So I'm going to throw this solution out. That was extraneous. Let's check the x equals 5 pi over 4. So let's check to see if it's true that cosine of 5 pi over 4 equals sine of 5 pi over 4. Well, cosine of 5 pi over 4 is right here. It's negative square root 2 over 2. And sine of 5 pi over 4 is right there. It's negative square root 2 over 2. So that one checks out. It's good. It's a good solution. So we're going to keep it. Our last one to check is the 7 pi over 4. So let's check to see if it's true that cosine of 7 pi over 4 is equal to sine of 7 pi over 4. And I can look right here and see cosine of 7 pi over 4 is square root 2 over 2. But sine of 7 pi over 4 is negative square root 2 over 2. Well, they're not equal. So because one's positive, one's negative. So this one's also a intruder, an extraneous solution. Does not belong. So our final solutions are these two right here, and we can say that the final solutions to our original equation, cosine x equals sine x, are x equals pi over 4 and x equals 5 pi over 4. Now that we have done all of this work, let's also notice that I keep saying you should know the unit circle. You should understand the unit circle. And if you know and understand the unit circle, you don't have to do any of this work at all. You can just look at what this says. It says, where is the cosine equal to the sine? Well, I know that there are only 2 points on the unit circle where the cosine and the sine are the same. Right here at square root 2 over 2, and right here at negative square root 2 over 2, negative square root 2 over 2. Those are 5 pi over 4 and pi over 4. So if I know the unit circle well, that's all I have to say. This is the only 2 points on the unit circle where the cosine and the sine are equal. So it's to say that these y and x coordinates are equal are at the points x equals pi over 4 and x equals 5 pi over 4. I'll say one more thing about that. Since cosine is the x-coordinate on the unit circle and sine is the y-coordinate of the circle, we're really looking for a point on the unit circle where x equals y. Well, what does the line y equals x look like? It's a diagonal line with slope 1 and y-intercept 0. So there's the line y equals x. And if I just look at the 2 points where the line y equals x intersects the unit circle, those 2 points are pi over 4 and 5 pi over 4, again the solution to this equation. So you can do this equation the long way analytically, you can do it visually in terms of knowing the unit circle, or you can do it using geometry. Where does this line intersect the circle cosine x sine x?